Okay, just a few reminders. This session is being recorded. Please make sure your video is off. I think it's off by default. And please mute the mic as you're speaking. Again, mic should be off by default. Plus Q adds you to the queue. Please use the WebEx chat for that. And add your name and affiliation to the virtual blue sheet. You can reach that via the meeting agenda. Also, please join this session Jabber Room by the IETF Data Tracker meeting agenda. And finally, we'd like you, when you ask a question, to state your full name. That makes it easier for the note takers. So I'm going to start the slide sharing. And we should be off and rolling. Okay, the note well, I'm sure you're all familiar with this. It's a reminder of IETF policies in effect on various topics, such as patents or code of conduct. It's only meant to point you in the right direction. Exceptions may apply. And the patent policy and definition of a contribution and protection are set forth in BCP 79. A reminder, by participating in IETF, you agree to follow the policies. And if you are aware that any IETF contribution is covered by patents or patent applications, you disclose that fact or not participate. And you acknowledge that the communications here will be made public and privacy is handled as per the privacy statement, and definitive information is in the documents below.
Bernard, can you switch to full screen mode, like clicking present or something?
I will do that now.
Thank you.
So if you're here and are watching the WebEx, you probably have gotten in there with the access codes and passwords. The agenda and the slides should be up on the agenda page. We're having a little bit of issue with that this afternoon, but I think everything is there now. We have an Etherpad, and folks should sign in there as we described. And the working group chairs for today are myself and David. So again, as a public service message, please mute your mics and turn off your cameras. Don't startle the iguanas or they might fall off the trees. So about the agenda today, we'll have our preliminaries, which hopefully won't take 20 minutes, but we'll see. And then we'll have Victor give us an overview of web transport and some of the requirements. Eric will then talk about web transport over HTTP2. Victor will take us through web transport over QUIC and HTTP3. And then we'll have a wrap-up and summary. As we mentioned, you can add yourself to the queue through the plus Q in the WebEx chat. We will take questions during these individual sessions, so it's different than the BOF when we get everything to the end. Well, please feel free to ask questions. Now, a few other things to take care of. We have a Jabber scribe, that's Lucas. I think we also want some volunteers for Etherpad note takers. Do we have volunteers for that?
Ron Gondwana, yes, I'm doing it.
Okay, probably 2 wouldn't be too terrible. So anyone else?
Peter Wu has just subscribed as well.
Awesome,
Okay.
thank you.
Okay. Great. David will be handling the speaking queue. Is there anything, any other agenda items or any other reason to bash the agenda? Okay. So next item in preliminaries is I hope that Doug is here with us. He's going to give us a little bit of an update on the status of web transport in the API in the W3C. Dominique, are you there?
Yes, I'm here. Hi, everyone. Dominique Azan-Mathieu. I'm part of the WCC staff. So as you know, the protocol work done in the Webtrans group is expected to support an API work that has been started in community group in WCC, the Web Platform Incubator Community Group. And we've started the process of creating a formal standardization working group in WCC. You see on the slide there a link to the repository where the charter is going to be developed. So we will do the formal announcement to the WCC community next week, but if you want to get a first look at this, follow the link. If you want to get in touch with me, the contact is on the slide. It always takes a bit of time to get the charter developed and approved in WCC, so we are looking at least a few weeks before the working group gets chartered, but right now the focus is on getting the right scope for the charter before the formal review process starts. So you're all very welcome in, again, go to the GitHub repo, file issues, get in touch with me. Wendy, my colleague Wendy Seltzer is also on the call today. I don't know if Sam is as well, but there are also good contacts if you want guidance on this.
Okay, thank you very much, Dom. Okay, so we will now turn the floor over to Victor. We'll be talking about the web transport overview and requirements. Victor?
Hello, can you hear me?
We can.
Okay, great. So the overview document is the first draft that we're going to discuss today. And from the charter, the goal of the overview is to set the use cases and the requirements that we put on this API. And those are important because this will help us to keep our higher level goals in sync with the owners of Web Transport API, which is likely going to be the before mentioned Web Transport W3C group. So next slide. And specifically in this presentation, I will try to first remind everyone what Web Transport is. Second of all, I will overview what currently is in the draft. And third of all, I will mention some of the open issues, that is things that the working group will have to discuss if we decide to adopt the draft, and we will have to resolve those issues before we publish it. Next slide. So what is Web Transport? Web Transport, first of all, it's an API that provides web applications with ability to connect to a remote server and exchange datagrams and unidirectional, bidirectional streams. That is to say, it is something that gives you something that looks a lot like a quick connection, but it's not necessarily just a quick connection because it's done from a browser. Web Transport Protocols is something that we define in this working group, is the protocols that actually allows that API to connect, and that's the protocols that the browsers and the web servers would implement to make Web Transport work. Next slide. So the overall goal of Web Transport is that if you want something like WebSockets, but for UDP, or WebSockets, but without head-of-line blocking, this is meant to fill that gap in current web platform, but it can also do much more. So the target applications is a wide range. It's anything from making online chats and push notifications, but we're specifically targeting the more latency sensitive things like web games or live streaming or cloud gaming, because those are the applications that particularly benefit from a lack of head-of-line blocking and would normally resort to using UDP in native applications to achieve those goals. Next slide. Just as a refresher, so the prior art here is WebSockets, which always work over TCP, so they have head-of-line blocking, an RTC data channel, which does not have head-of-line blocking, but it's only peer-to-peer, and it does not support the client-server mode that well. And web transport is meant to fill that gap of client-server unreliable transport. Next slide. Next slide.
Somehow I got stuck. Hold on. There we go.
Okay, so the first thing that draft defines are the requirements. That is to say, what do we require of every individual transport that is a part of web transport and that's exposed to the web? The first requirement is it has to use TLS or semantically equivalent protocol like say DTLS or QUIC with TLS. That is to say, or otherwise provide all of the properties of TLS that gives us confidentiality, integrity, authentication, and a lot of stuff we expect from our protocols in 2020. The second point is that it has to maintain what's called consent to send, and it's maintained continuously. That is to say, when your web application connects to a server, that server must agree to continue to talk to your web application, otherwise you could DDoS people. It has to have congestion control in order to not overload the network. It has to ensure that the server is aware it's talking to a web transport client and not some random native application. And this is important because otherwise random JavaScript applications can launch cross-protocol attacks. And that's what the particular focus of WebSocket design is, how we avoid that. It must support the web origin model, i.e. let server filter connections by origin using a protocol that's like CORS. It must support, so another requirement is that any web transport server has to be identifiable by something that is a URI, because this is how we integrate with parts of web security, like content security policy and other. And the final requirement is that it must have the client and server. You can connect to the same server at the same time from different browser tabs, and it just works. So there must not be any like server global state that is also basically, otherwise it doesn't work in a browser. Next slide. Martin, do you want now, or should we wait until the end?
Quick. Do you want? I'll wait till the end if that's.
Yeah, let's please save the questions to the end of each presentation if that's all right.
Thanks.
All right, Bernard, is there a slide before this? So the other things that this draft defines are the common features that the features that we expect from web transport. The two features that we expect are streams and datagrams, and streams are arbitrary sized and reliable, and when possible, they are independent, which means they have no head-of-line blocking, and they're cancelable, which means when you reset a stream, all of the data goes away. And then we have datagrams, which are effectively have the same properties as UDP when that's possible. Next slide. So streams, as I mentioned, streams are both bidirectional and unidirectional. They can be initiated by either client or server, which is the reason I mentioned that is, for instance, HTTP. When if you initiate everything, it has to be pretty much initiated by the client normally. And there are also, so with streams, while we define streams, there are some open questions. Notably, we need to define the state machine of the streams. And the particular complication here is that we intend to use both HTTP2 and HTTP3, but QUIC treats resets differently from the way HTTP2, because in HTTP2 or TCP, the reset closes both halves, but in QUIC, you can only reset your own sending half. And there is also the question is, in all of those protocols, we have stream IDs. Do we want to expose them? And if not, that would mean some things for how people build protocols on top of this. Next slide. Datagrams, just as a reminder, it's something that's UDP in Quick. This is specifically based on Quick datagram, which is the easiest way to send application over Quick, in the sense that this is just, you take a Quick frame and you put your data into there, and you're responsible for ensuring it's reliable. Next slide. Terminology. So there is a definition. There is a section of definitions in front of the draft, but there are some interesting questions which we should sort out before we start writing a lot of text. Otherwise, we will be in a lot of confusion. Notably, we often call something a transport, but a transport can mean a lot of things. It can mean a protocol, or it can mean TCP or UDP, or it can mean a specific connection, and so that's confusing. So I propose term transport session for a specific instance of web transport, and I'm not sure what's a good term for transport protocol. And finally, we usually use term streams everywhere, but in some cases we use term message, and streams and messages are same, but in some contexts they could mean different things, and we should figure out which of those we use and how, and before we start writing more. Next slide. So there is also an interesting open topic, is what do we do with priorities? Because so if it's like we say that this is something that is vaguely compatible with Quick, Quick expects its libraries to provide some API to determine which streams are transmitted earlier and which streams are transmitted later. It is not clear to me on which level that question even belongs, because this is not purely a protocol issue, because it's not immediately reflected on the wire. It is also not a pure API issue, because API describes what happens and how applications can access it, but this is kind of a concern for a layer in between them. It's unclear whether we should even talk about that question or just punt it to the W3C or whatever. So next slide. Yeah, so this is basically the summary of the overview document. The draft has more text, it has security considerations and other form of analysis and more minutiae. But so I want to ask for questions, and after that I want to ask whether people think we should adopt this as a starting point.
All right, we are now going to go over to the Q discussion. So as a reminder, please type Q+ or Q+ into the WebEx chat. So Martin Thompson, please kick us off.
Yeah, so Martin Thompson. Victor, thanks for going through all of this. There are a few things in here that I think we've had on our plate for a little while. It'd be good to start working through those issues one by one. For me, the issue that I wanted to talk about was multiplexing. I think there's probably some question in your requirements as to whether that could apply to multiplexing or not. And I'm not very clear on whether we think that's a requirement or not.
By multiplexing, you mean whether it's can multiplex multiple transports on the same connection or individual?
Effectively, yeah. So imagine you have different origins that are talking from the same browser to the same server. It might be possible that they could share a connection. That introduces some interesting questions, particularly when you talk about your different transport options.
So the way the draft currently addresses it is that it leaves it up to individual transport to decide how that works. So it could allow to either multiplexed or non-multiplexed. I have slides for later, when we discuss the specific transports, I have some slides discussing this issue in more depth. About
that might be the right answer then.
Yeah.
I just didn't see it in your presentation. That's all.
Yeah, they will be in like when we discuss HTTP transport and quick transport. Yeah.
And the other thing is, I think we need to be careful again to separate the local decisions that endpoints make about prioritization and the signaling that they might actually use in order to coordinate that. I think in this case, we can probably put the signaling out of scope, but it's probably necessary to have some sort of signaling between the web application and the browser in order to make sure that the transport is properly used.
The question, I definitely agree with that. The question is, where do we address this question in protocol documents or in API documents?
Yeah, I suspect this is a purely API question.
Okay.
That's my suggestion.
Thanks, Martin. And before I go next, I just wanted to clarify something. We're asking here about adoption of Victor's overview document. We're not saying in any way, shape, or form that everything in the document has working group consensus. The question that we're asking the working group is, do people think that this is a good starting point? And then we can go and revisit anything we want in the overview document. But the question is this, at the current point in time, a good starting place? And with that, Mark Nottingham, you're up.
Hi, thank you. Hi, Victor. I just had two things. One, a question just to make sure I understand. I support adoption, by the way. I think that's fine with the proviso that David just put in. So just to make sure I understand, at a high level, you've got a quick transport and an HTTP3 transport and an HTTP2 transport. And the latter two are so that you can run web transport concurrently with sessions in those protocols and reuse the same connection, which seems sensible. You don't define an HTTP1 transport. So, many of the deployments that these are going to be in, you're going to have, multiple hops, and some of those hops might be HTTP1. So in those cases, if you can't make a connection, a separate connection using one of the defined protocols, is it just it doesn't work? There's no downgrade? Is that the case?
The current answer is that I've actually was just thinking about this. The answer is that in order for web transfer to HTTP transfer to succeed establishing the session, it does have to support either H2 or H3 on each hop. Okay. And that is a conscious design decision because it is not clear to me how that would even work in H1 in first place.
But that's a great question, Mark. Do you have an opinion?
I do have an opinion. I think that's very sensible. I think that it'd be better to fail hard and predictably than to try and map it onto HTTP1 and have lots of weird corner cases.
Yeah, I would say the API currently does not do a good job of describing when you fail or not, but yeah.
Okay, that may be something to look at then. Okay, and I guess the second part of that first question then is, do you have a fallback to WebSockets? Is that something that you've considered?
That is not a document I've actually written. It's called fallback transport, and it is in fact like effectively simulation of web transport semantics over WebSocket.
Okay, so that's a great answer. Okay, thank you. It implies the semantics here are mappable to WebSockets then.
Well, they're not directly mappable, but they're simulatable.
Thank you. Yeah, great. And the second item then, much shorter, to the terminology question, please build this good in this world that we still have left. Do not call it transport sessions. That's going to be massively confusing. And I would really encourage the working group to think about using a different name like WebSockets 2.0 or something like that. I don't want to talk about that today because I think this is probably the worst possible forum for that kind of discussion, but just put a pin in for that.
Thanks, Mark. Lucas Perdue, you're up.
Hello, Lucas Perdue here. I want to cut short my comment from what I initially had in mind, keeping in mind what David just said, but with the slide on priorities, put into my head something around, is this purely a kind of a requirement to want to, of web transport, to fulfill the should of quick to allow only prioritization of streams? Or are you going to try or want to prioritize datagram flows against streams?
To answer this question, so streams relative priority is not just fulfill the should of quick. It is just like, in general, we believe that this is something that makes a lot of sense for application to control, and like it would be weird if native applications can have control over it, but then web applications can do. The priorities of datagrams to stream is a very difficult topic. I don't have any slides, but this is probably something we would need to think through, either like when talking about datagram draft or in the API document when we define priorities. But basically, it is not entirely clear to me how that should work.
Yeah, the API document doesn't have anything about priority or of anything at the moment.
Yeah, I think that it should have that at some point. There is an open issue to deal. In fact, like I think if you go to the GitHub of the API document, it has like at least 4 issues which deal with that very topic of how to prioritize streams and datagrams.
Sure, that answers my question. Thank you.
Harold Alvestrand.
Thank you. I was happy, Harold Alvestrand, Google. I was happy to see the stream identifier listed as an open question, because it looked very odd in the overview draft to have a lot of very high-level description of what this protocol is going to do, and then suddenly come to, oh, and by the way, we have streams with 64-bit, exactly 64-bit IDs. That just looked weird. So I'm happy to see that this is an open question.
Do you have an opinion?
No. I think we either need to say that streams can be identified so that you can have data in one stream referring to another stream by its ID, or we need to say that streams cannot be identified, and if you need to identify them, you need to build it yourself. Pick one.
For what it's worth, the current answer where I've been leaning towards to is no, because because it turns out that we can't really use IDs with HTTP transport, because that exposes information about what else is happening in the connection. So if we're not getting those for free, there is no benefit to providing them instead of just asking application to make its own.
Good. That kind of biases the question. The other point is just I wanted to relay the experience of priority and WebRTC, which was we started off by confusing ourselves with using the word priority to refer to both what the local node should do and what the network should do. And we defined it without defining exactly what the local node should do for different priorities. Those were mistakes, and I hope you don't repeat them. I mean, if you want to have something that people refer to as priority, you have to define exactly when it influences things, so that it's actually possible to write a test for it. Currently, priority is not testable in WebRTC, and that's sad. Okay, that's it for me.
Thanks, Harold. Spencer Dawkins.
Sorry, you can take me out. Thank you.
All right, that brings us to the end of the queue here. Let's move over to the next presentation. Eric Kinnear.
All right, could we grab the next slide, please? So if we go back one very briefly, a quick note here that this is the product of a lot of work by a lot of excellent individuals. I'm the one speaking to it, but the folks listed on the slide have put a lot of time into putting this together and helping merge a lot of different ideas. All right, next slide. So since we last talked about this, and we've been talking about this at IETF 106 and a little bit before that, one of the things that came out of the BOF, where we saw presentations from multiple different people who are trying to solve very similar things or the same thing with decently similar mechanisms, was the idea that we should all sit down and talk to each other and kind of come up with a single idea. And so that's exactly what we've done. So we've gone and taken the 3 drafts that were listed here and said, we should make the mapping of the protocol bits for web transport onto the HTTP versions look roughly the same and incorporate the things that were coming out of each of the drafts that are listed here. So if we go on to the next slide. The end result of that is something that maps onto H2 and H3. We've talked a lot about quick in web transport previously, and so a brief reminder slide here for H2 is that there's a lot of things that H2 provides, which quick the transport now provides, as well as H3 by proxy, with some interesting caveats that will come up and we'll need some more discussion later. The biggest one being the point at the very bottom here, which is that HTTP2, when running over TCP, does not necessarily allow you to have unreliable data transmission or out of order data delivery. And so one of the questions that's going to need to be solved is how you cope with having a preference or a requirement and potentially the distinction between the two for unordered delivery or unreliability, and how that's expressed through the API and communicated back once you establish a web transport session. Next slide, please. So we took the shared concepts that we have between the 3 drafts and said, okay, let's define the mapping of web transport onto H2, which is another way of saying bidirectional communication over HTTP that's running over TLS and TCP with H2. And that breaks down into effectively negotiation and session establishment for how do you actually do the protocol mechanics and bits to negotiate this as an extension on top of HTTP2. And then once you've done that, what does it actually look like to send data, and how does that fulfill the needs of the web transport API? So if we go to the next slide and start with negotiation. The key here is it's effectively a HTTP2 extension, which is negotiated with a settings value. So any endpoint that wants to speak web transport sets setting enable web transport. And we ended up settling on using the extended connect handshake to do the negotiation of web transport as the token for use in the protocol pseudoheader, which means you also need settings enable connect protocol. So if you put settings enable connect protocol and settings enable web transport together, you are declaring I am willing to negotiate all of the things that follow after this slide, and you're going to look for web transport in a connect message. Next slide, please. So the draft talks about this in a good bit more nitty-gritty detail, but the high-level overview is you effectively have an authority and a path which defines a HTTP2 transport endpoint, and you make a connect request to that location using extended connect, saying I'd like to speak web transport. And that establishes what we're going to call a connect stream, which is effectively the handle to the web transport session, for lack of a better word, and we may want better words. But there's no data exchanged on that connect stream. And from there, you create subsequent actual web transport streams, which either endpoint can initiate that are referencing that original connect stream. And so that's the life cycle of all of those streams is directly tied to the connect stream. So if we go to the next slide. we have a high-level picture, which we'll fill in some more details of later. But effectively, if I have a client and a server, and we'll talk about intermediaries a little bit later, but if I have a client and a server, I can establish with Connect a WebTransport Connect stream, and I can have either side, either the client or the server, initiate WebTransport streams that are associated with that Connect stream. And that becomes important for routing information, especially when we start talking about intermediaries, because the Connect stream is established only from the client to the server and is required before either endpoint can start unilaterally trying to initiate new streams. So if we go to the next slide. So once you've got a stream up and you're ready to use your WebTransport stream, data is only exchanged on the WebTransport stream, not on the Connect stream. And establishing that is using a new frame, which we're calling WebTransport headers or WT headers, which looks just like a regular headers frame, but either endpoint can send it to begin the stream. And it has an additional field in it that allows you to put the reference to the Connect stream that is the session. And that Connect stream is the information that you need to be able to tell where frames on this stream need to go. So if we go to the next slide, we have the actual bits. This looks exactly like a headers frame. The only thing that's different, I bolded in the middle here, which is the Connect stream ID. And so you effectively have a place to put the reference back to the Connect stream that this one would like to be routed with. Next slide, please. We have an example here, and this is walked through a little bit in more detail in the document, but to make it a little more concrete, you start by having to negotiate that, yes, we all support this extension, and that's all fine and dandy. You then send your Connect message with protocol WebTransport to whatever endpoint you'd like on that server, and it can come back and say, yes, this is great, or perhaps it says, no, some other hop that I'm going to take doesn't support WebTransport, and I'm not okay with that, or whatever else it needs to do. And that kind of comes back to Mark's question about what do you do when there's a non-WebTransport capable hop along the way. Next slide, please. And once you've done that, you can start sending a WT headers frame, which has its own stream ID because it is by itself a stream, but it also has that field that references the Connect stream. And so it says, hey, I'm part of that Connect stream. And from then on, you have a fully functional WebTransport stream, and you can start sending data frames or whatever else you need to do with that stream, just like any old HTTP2 stream. Next slide, please. To fill in our earlier picture, to make things a little bit more concrete, that Connect stream is still there at the top and partway through, and the pieces that we've filled in are effectively that you reference that stream from each of the smaller ones, with the noted example being the second one down at the bottom, where the server is initiating the only WebTransport stream that is part of that overall session. Next slide, please. This is a very quick note that pulls up the same stream state machine that we've always had for H2, which is that they remain exactly the same. The client still needs to initiate all of the Connect streams, but once you've done that, either endpoint can initiate the WebTransport stream. And the last piece there is that the life cycle of all of the WebTransport streams is tied to that of the Connect stream, in part because it contains the routing information that you need. And so if you close the Connect stream, all of the other streams that are referencing it need to also be closed. And there's protocol bits that are spelled out in the document for the different mechanisms by which they get closed and how aggressively you need to follow that. But the core concept is if you lose the Connect stream, everything else underneath it needs to go away as well. Next slide, please. The last little bit here, which is not noticeably little, is the considerations around intermediaries, and there's a bit more text in the document about this, but at its core, the idea is that a WebTransport stream follows the same path as its Connect stream for each segment that is using WebTransport. So in this example, if I have a proxy and I ask the proxy to go connect somewhere, it can establish its own WebTransport streams to the server. And if we go to the next slide, we can see that in this case, the green arrows are now, once the client has established full connectivity all the way to the server, the proxy knows where it needs to route the WT headers for the stream that the server is trying to initiate back to the client. And so that's part of the main reason to have this other long-lived stream around for routing information, is that you need it for routing information. And with that, next slide, please. To wrap things up, effectively what we're trying to do is define an H2 extension, which we negotiate like many extensions with a settings value. We have settled on having extended connect as our starting point for the negotiation and establishment of routing information. From then, we take web transport streams, and they actually carry the data. They can be established by either endpoint, and an intermediary has effectively requirements it needs to make and fulfill on the actual web transport data that's going by to follow along with wherever the connect streams are going. Next slide, please. That takes us to the end.
All right. First up in the queue, Mark Nottingham.
Hi. So the connect stream. I understand why you'd want to use that if you're talking to a proxy that you've configured. But if I'm sending WT header, can we go back to the example slide with the WT headers on it? If I'm sending just, if I'm talking just with the server that I've connected to, I think WT headers has all the routing information I need in it. What utility does the connect stream have in this case?
Significantly reduced utility. At that point, you could do things with only a WT headers frame as long as you are okay with the client receiving it out of the blue from the server. And today, the client effectively signals its willingness, and the particular web transport details that it has said I'm negotiated for this particular web transport conversation via the connect stream. So if I wanted to have two separate, what are currently called web transport sessions that are each separately multiplexed with within an H2 connection that also has other requests and responses going by on it, you would potentially want additional metadata more than just a single connect stream ID in the WT headers frame. But that's much more minor than the routing thing.
Okay, I can believe that. I guess the thing that's pricking at the back of my head is that this seems like it's a pretty significant stretch of the semantics of connect, which are already pretty abused. But that's something maybe we can talk about later on.
Indeed, yes.
And, Victor, if you want to jump in, go ahead.
Yeah, so the reason that connect is always necessary is that the way I think about it is with WT header stream, the routing is always attached to that connect, and this is like there is no information in WT headers that is ever used to route. That is the defining property of WT header-based stream is that they're routed exactly as the connect stream. And this is why, so even if it's like a direct client to direct server connection, this is important because when you're in a web browser, you want to make sure that all of the, for instance, streams that servers open to client go to the same browser tab and the same JavaScript listener.
Yeah, that makes sense. I think we're trying to clean up the semantics of connecting core, and I'm feeling like this is backsliding. So we'll figure something out. If you need a new method, it shouldn't be.
I think that's something we'd be super interested in continuing to iterate on. So very much yes.
All right, Martin Thompson.
Yeah, Martin Thompson. Thanks for walking through this, Eric. I had a little bit of trouble understanding the draft, and this really helped. I'm still having trouble understanding how this achieves the requirements that Victor laid out in the previous presentation. In particular, I searched for the terms unidirectional and datagram in the draft and found one instance of unidirectional that was talking about push. So can you explain how you imagine that might work?
So we don't cover any of that in the text, and I think we don't even yet have a GitHub issue on it. So we most certainly need that. But that is one of the things where, as we talk about doing the things as the underlying protocols and transports that you're mapping WebTransport on lose the primitive capabilities for things like datagrams or things like out of order delivery or even unidirectional streams. I think the two things we need there are, one, the clear expression of that in the API so that the users can either say, I need this, and I'm willing to say, I don't even want to try if I don't have it, versus this would be great, thank you, but I'm okay. I'd rather have a connection that was less good than not have one at all. So that's part one. And then part two is we need to, when you say I'd like it, that could turn into, framing datagrams in their own frames so that you can preserve those boundaries as they're going over the TCP stream. The protocol bits of what you put on the wire to represent that for both unidirectional streams and datagrams seem like there's multiple options, but at least one fairly straightforward one is to frame the datagrams and potentially half close some of the streams.
Right. So in order to do that, you need to have clear understanding between both endpoints that the stream is only being used in one direction. So you would need signaling for that one. Related to that is a question about the numbering space that you're pulling from. It looks like in the draft you're pulling the stream identifiers for these new subordinate streams from the global numbering space, which means that you're using the same accounting that we use for concurrency and whatnot. Is that going to be compatible with datagrams?
That is a very good question, potentially very thorny. So right. we will need to sort that out and either put them in their own space or mirror some of the weirdness that is currently around quick datagrams versus H3 datagrams, where some of them have identifiers and some of them are these things that just float around out there.
Yeah, and the final question, I guess, is, and maybe it's a comment, I don't know. This header block fragment in your WT headers scares the bejeepers out of me, and it potentially isn't necessary given the rest of the design that you've described. I don't know of any use of individual per datagram headers that needs exposure to the intermediaries and the HTTP layer here.
If I'm understanding you correctly, you're effectively saying that those header block fragments should have been carried by the connect headers themselves. Right. And so therefore you don't need them in the effectively the child streams, because the parent should take care of all of that for it.
Right, and particularly because this complicates things with respect to HPAC and whatnot, I would prefer to see them out.
I think that's worth a little bit more discussion, because some of the folks using these, I think, are expecting to be using the WT headers frame as effectively a full stream that is doing requests and potentially responses. But it's a very valid thing to dig into and see if we can't just sort that out.
Right. I see Alan commenting. Yes.
Yeah, this is Alan Frindell. So I agree that if you envision WT headers encapsulating a datagram, then a headers block there doesn't really make any sense. But if you're using them to create streams, then it seems like being able to take advantage of the ability of the HTTP2 connection to convey structured metadata, name value pairs, is one that is, I don't know, it's too good to pass up, in my opinion. You can leverage compression. You can send structured metadata back and forth without every app developer who wants to use a WebTransport stream from having to reinvent those, semantics on their own.
Yeah, unfortunately, I think this is one of the failings of the HTTP2 design, in that it mixes those two layers in ways that are non-obvious, and this is one of those crossing of the layers that I'm uncomfortable with. But yes, we should continue this conversation elsewhere. I agree.
Sounds like a good plan.
Victor, were you going to quickly add something?
Yeah, I basically this is one of the questions. I'm both very receptive and like I agree with Alan that the idea of like ability to use unified metadata format is really appealing. At the same time, other thing is that since we're defining a model here, which is like allows you to switch between many different things, it is also not entirely clear to me whether we want to make those headers part of that model or not. And what does it mean for that particular header block in particular?
All right, thanks, Victor. I am now cutting the mic lines, and we're still going to drain the queue. Ben Forts, you're up.
Hi. So I have a comment which is sort of the opposite of Mark, so that means it's probably not very good, but I'll give you the idea anyway. The web transport endpoint is identified by a path, and that path can be a secret. So the fact that I am doing web transports on the server can be a secret, except for the settings frame, where it seems like it needs to be negotiated up front before there's been any kind of user authentication. And so it seems to me that in the context of Connect, in some sense, that that settings frame is superfluous. That is, by performing the Connect and specifying the appropriate web transport protocol value, the client is informing the server that they support this frame, and the server in turn is confirming that if they return a 200 response. So anyway, I guess I just would like to suggest that you think about whether that settings frame essentially leaks information about the server configuration that not all clients may necessarily have permission to know.
And I thank you for bringing that up, because I think that is a very valid consideration. And one of the things that has been a topic of much conversation in that area is whether the fact that when Extended Connect says, hey, here's the protocol, you are technically supposed to be able to cope with protocol tokens that you've never seen before and don't support, and that is kind of supposed to be the negotiation mechanism. And so at the moment, we've currently kind of gone with the super extra, I totally declare, I swear I can handle this mode, which does indeed both declare up front and potentially starts to interact more interestingly as you try to do things in fewer round trips or 0 round trips. So potentially slimming that down or settling on a different answer is something that would be nice to sort out and come up with something that we all think is a good plan to go forwards with.
Thanks.
Lucas Perdue.
Hello, Lucas Perdue. So Martin stole a lot of my thunder in terms of the concerns on the WT header frame. Could we go back to that slide quickly? I just wanted to add a little more color around some of Martin's comments, but I'll keep it brief. Yeah. Well, I'll continue talking while we're waiting. Yeah, when I look at that frame, it both worries me and makes me ask, what is it in that frame that you care about? And it's just the field that contains the Connect stream ID. You know, there's a whole load of worry about whether we've negotiated an extension or not, and whether the receiving endpoint is going to ignore that frame or not and commit state into the header compression, etc. But I just wonder if there's a different way to look at this, and just to include that Connect stream ID as a pseudo header into a normal headers frame, and would that achieve the same requirement that you have? Like, we don't need to go into designing it, but you know, the general comment here is, I don't like this thing, and I think there's different ways we could solve the problem.
Yeah, I think, thank you, and while trying to resist going into designing it right now, I think it would be great to have that design conversation, and if there are other ideas and other things that we could do that would be better, that would be great. I think Alan touched a little bit already on some of the reasons why the rest of this looks that way, but if you stick it in a pseudo header and it could still look similarly without being quite as scary, that might be cool. So yes, please, let's talk about it, and thank you for saying so.
All right, Harold?
You may want to unmute Harold.
Harold going once, going twice. We'll pick you up after Jonathan. Jonathan, go ahead.
Jonathan Lennox. So I'm a little bit perplexed by the WT headers frame and people's comment that maybe there should be an F inserted there. What I'm particularly looking at there, it has its own, effectively URI, notably the path, which is separate from the one in the connect. And I guess my question is, can that be different than in the connect? And if so, what does that mean? Because it seems like if you could do that, then potentially a reverse proxy could route it somewhere else, which then your transport stream is not following your connect stream, which breaks your model. And if it can't be different, why do you have it?
Yeah, so I think can it be routed differently, I think needs to be a hard no. I think it needs to follow the connect stream. If the fallout from that is that it would be worth overloading into the connect stream all of the information that you would have carried in here, that's one potential path we could take.
Yeah, because particularly, I mean, obviously this is the HTTP2, not the HTTP3 model, but for datagrams, I want the overhead to be as small as possible.
One of the interesting things that is not necessarily carried by the connect stream is if the server is attempting to initiate something to the client. It is a very interesting question of what does the, how does the path that you send to the client get communicated through the connect stream if you go to take it that way. But also the semantics around that are probably worth spelling out at all and much more clearly than they are now, which is to say not.
Okay, yeah, and I guess I just, anything you can take out of your do if it's going to be used per datagram.
Yes, I don't think the intention is to use a WT headers frame per datagram. But we clearly need to define that at all and very much with care.
Right. And Lucas as JavaScribe?
Yes, as JavaScribe, I'm channeling Harold, who asked, where is the origin carried? And is it associated with the stream or with the connection?
I believe it is associated with the connect stream.
It's a header on the connect stream, so it follows the standard course protocol.
All right, thank you. This brings us to the end of this presentation. As a reminder, Victor and others, please remember to state your full name before speaking. And Victor, you're up next.
All right, so Eric has described how web transport over HTTP2 looks like. I'm going to describe the other proposals, web transport over HTTP3 and web transport over QUIC. Next slide. So web transport over HTTP3, aka HTTP3 transport, is it's exactly what Eric just described, but over HTTP3. Notable features of it is that it has datagrams, which are supported using so the datagrams are now real QUIC datagrams, and they are sent using the QUIC datagram frame, and they use the connect stream ID as, and it ties into that draft, which defines what datagrams mean in HTTP3. So as a disclaimer, I've not updated the draft since we agreed on all of the design details for HTTP2 and HTTP3 transport, so I will still need to update it to include all of the details from Eric's draft, but the notable differences from the one which presented at the last BOF is that the negotiation of web transport is entirely settings-based. We use a stream ID of the connect stream instead of creating a completely different ID space. And as I said, this is like the WT headers has the WT header block. That's also a notable change, which is something, as we've already talked before, we will need to discuss. As a clarification, the streams can have it. The datagrams have the minimal overhead. That is to say, the datagram has it's the datagram frame, and after the datagram frame, it has the ID and of the connect stream it's associated with, and the rest is the application payload. So this is basically what HTTP3 transport is. Next slide. So so the other transport that we have proposed previously is a quick transport. So what's a quick transport? Quick transport is, so the premise of web transport is that it's API that provides effectively quick-like application semantics, but it works for the web. And quick transport is so it is the minimal protocol built on top of Quick, which does that. That's to say, what do we need to add to Quick in order to meet those requirements? And the first thing we need to do is to define a special ALPN value in order to prevent cross-protocol confusion attacks. Second thing we need to do is we define a URI scheme because because we also need URI schemes in the requirements to identify those connections. The third thing is we define a special stream, which is effectively like connection level headers, which primarily exists for the sole purpose of informing the server of what the origin of the initiating client is. And this way, every quick transport client gets a dedicated connection whenever it establishes the session. So effectively, a single quick connection and quick transport is equivalent to a connect stream and HTTP transport. Next slide. So this is just elaboration of how quick transport URI scheme. It has part with path, which is sent together with the origin, and it has the server name, which is sent as SNI in TLS handshake. And it has port because we need to identify the port. Next slide. So now that I've described the other transports, we need to decide, okay, do we actually need all of those transports, or do we want to reduce the set of the transport to some smaller set of transports? And the next slide is the overview of which transports we propose. So quick transport is the one I just described. HTTP2 transport and HTTP3 transports are effectively web transport over HTTP2 and HTTP3. And the fallback transport is something that I've alluded to before and we've discussed, but something there is no actual current draft, but multiple people have expressed interest in this, is we simulate web transport semantics on top of WebSockets by creating something that is effectively a moral equivalent of HTTP2 over WebSocket. And the question is, do we need all four of those? Maybe we can somehow reduce the number. And next slide. So this is next slide. So let's start by trying to see how those transfers different. And the most obvious dimension in which they differ is well, quick transport and HTTP3 transport use quick, and H2 transport and fallback transport use TCP. And we want to run this over quick because that's how we achieve partial reliability, etc. but we also want to have at least one option that runs over TCP. So if Quick is blocked in the network, we can fall back from Quick to TCP. Next slide. So there is another interesting axis of this decision is that, so in Quick Transport, as I said, you get a dedicated connection for every instance of a transport that you establish, whereas this is not true and intentionally not true in HTTP2 and HTTP3, because the entire point of HTTP2 and HTTP3 is that if you are a client and you connect to the same server endpoint, you get to share the existing physical connection. And this is good because we want to reuse the same connections in order to, so that they can share congestion context, so they can avoid delays incurred by slow start, so that we can cut down on handshake latency, etc. Next slide. So, however, there are some interesting reasons why one would want a dedicated connection. So first reason is that when you have a dedicated connection, you have a dedicated congestion control context. And that congestion control context is really helpful because it provides you with information of how am I using the network and how fast can I send, because effectively in traditional congestion control algorithms, you can infer that from CLIND over RTT. In rate-based algorithms like BBR, just output your rate. And this is very useful for transferring media, especially real-time media, where you might decide that you need to really drop your bit rate because otherwise you're going to induce get a self-induced delay. There is a similar thing that when you get a dedicated connection, you can export statistics like packet loss rate, which is not trivial to do with shared transport because frames from the same transport can be used, like the same connection can put logically isolated transport onto the same quick packet. So it's not clear what that statistics would even mean. And the third related reason is that there are some TLS level connection knobs we can use because for security, we rely on TLS, and TLS is a connection level property. So if you want to do client off, or if you want to do something about changing how you handle server certificates, you would need to do it on connection level. So I will note, yeah, so those are some of the reasons one would want a dedicated connection. Next slide. So this is like the overview of the key reasons that were driving the separation between those transports. And by those two axes, if you split them, you will find that those transports kind of fit into like four corners. There are some other related advantages of different transports. For instance, one of the main reasons people are so interested in HTTP2 transport and HTTP3 transport, that HTTP is really widespread and has a very rich ecosystem. And if that ecosystem eventually adopts if that ecosystem adopts HTTP transport, we can reuse that. And this is, for instance, something that I believe Ripped folks were really interested. The second reason is HTTP has practical solutions like for things like redirects. So if you start an extended connect, you can get a redirect somewhere else. And like those kinds of problems are already solved by HTTP. And then Quick Transport would either have to solve them or punt them to the application. Quick Transport has an interesting property where if you have a protocol that already runs on top of Quick, you can expose it to the web pretty much without any implementation effort. I am not sure, I'm not saying, it is not entirely clear to me how compelling proposition this is, but in practice, I've observed that a lot of applications start as native applications, and then they decide they need a web version. And if they are writing something that is not HTTP based on top of that, they have their regular native stack, and then they have a WebSocket stack or something like that. And my intuition is that this would allow to avoid that confusion or at least mitigate it. Next slide. So there are few ways we can go around it. One is that we adopt just all of those transfers that's listed. The second way is we adopt only HTTP transfers and then think how we can turn HTTP transferred into something that suppose both is shared by default, but whenever it needs to, it can be a dedicated connection. I tried to do that as an exercise, and I found that there are lots of weird issues about how you treat things like out service and routing when you try to do that. But I'm not saying that's impossible, and I'm not saying that's the wrong way. And the third option, which I've also heard some people propose, is that we just adopt HTTP 2 and 3, and then we just talk about dedicated version when we are sure we need it. That is to say, right now, we don't have a good understanding of how media would work, how sending media would work over a shared HTTP transport. However, once we gain practical experience, we might come to conclusion like having bandwidth estimates from dedicated congestion controller is essential, or we can deal without it and work just fine. And this is effectively means that we would postpone that question until we actually need to decide on it. Next slide. Yeah. Actually, next slide is just discussion because this is the end of, yeah. So let's go into the queue.
All right, Lucas Perdue.
DQ me, I completely forgot what I was going to ask. Sorry.
All right, Mark Nottingham.
Hi, could you go back to the some other considerations slide, a few slides back? And while they get there, there it is. So regarding the fallback transport, I don't think you're going to need it on most connections, and that most of the infrastructure is already going to be TLS protected. In cases where you have a man in the middle violently insert itself, it's not going to want to support anything anyway. So, you know, the only reason to use the fallback transport, I think, is for compatibility with widespread WebSockets frameworks on the server side. And I think there's a judgment call to whether actually trying to include those is a good thing or not. But I don't see a burning need for it. Regarding this slide, I feel compelled to point out, as I've pointed out to others this week, that just because you say it's related to HTTP doesn't mean you get all the infrastructure for free. There's going to need to be significant work in load balancers, CDNs, and web frameworks to take advantage of this. It's not just magical. And for existing protocols to run on top of Quick being adaptable for free, I have questions about that as well. I think they're going to have to make some changes too.
To comment on this, I do understand that it's a lot of work, but my belief is that this still puts us at advantage compared to situation with, say, WebSockets, because WebSockets have been historically just so different from HTTP that frameworks which did HTTP often did not even consider adopting that.
Sure. So I mean, the assertion here would be closer to say that if you've already done WebSockets, this is a fairly easy migration.
Right. Thanks. Martin Thompson?
Yeah, Martin Thompson. This is the slide that I wanted to talk about as well. I don't think we need 4 protocols. It seems to me like we could probably get away with 1 from each column if we were concerned about the penetration of UDP and Quick into the things. Yes, 1 from each column is probably where we're going to end up. For me, I would think very, very hard about the distinction between your dedicated and your pooled, because the complexity of the pooled options is significant. And to Mark's point, I don't think that the benefits that you'll see automatically accrue to the pooled transports. If you look at the way the infrastructure works and the way that people have deployed WebSockets, for instance, they haven't been able to take advantage of any of the infrastructure benefits that come with HTTP at all. And a lot of people will be deploying WebSockets endpoints on completely separate names with completely separate infrastructure. And if anyone was at the RIP-BOF yesterday, they will be essentially building from the metal up in those cases. And that people are comfortable with that for some reason, and that's fine. I would actually argue more toward the end of the dedicated things and think about fallback transport being just WebSockets. If you look at the proposals for changes to WebSockets, there's not a lot of a delta between what it is that we're doing here and what it is that's being proposed there. I think someone's proposing datagram transport for WebSockets, and that would make a pretty big difference to the feature gap between WebSockets and what you're proposing. So I'm almost at the point where I could say quick transport is the only thing that we really need to sit down and define.
Thanks, Martin. Eric Rascola.
Yeah, Eric Rascola. I mean, Martin and I concur on the big picture, which is we don't need 4 protocols, and the fewer the better. I guess let me start with my overall thesis, which is we should define the ones that get the job done minimally and do something, and then if we decide we need more, we can always define more, but let's not like set ourselves a giant job. I think that clearly means something that runs over UDP and something that runs over TCP. My intuition is the opposite of Martin's, that we wanted H3 and H2, but I think I could be persuaded we wanted quick and fallback perhaps. But I think that like defining all 4 is like super bad. At least right now. So I guess, my put is like, this is not a great forum for trying to figure out which of these 2 or one we will adopt. We should adopt none, but like try to figure out how to solve the problem and then do some adoptions relatively soon. It's not that I think any of these points in particular are bad, though I'm not unsure about the whole fallback thing, because I haven't really seen it. It's just that I think there's too many.
Thank you, Ecker. Tommy?
Thank you. This is Tommy Pauly from Apple. I tend to agree with what Ecker was just saying. I mean, in general, I'd like to see probably one column, either the quick transport plus fallback transport or the H3, H2, such that we have relatively equivalent layers. I see how doing just the lower level transport is simpler, but I think one of the arguments to bump up a layer is that may be able to combine solutions with other things that are going on. I know that a number of people here also were at the MASC BOF that was earlier, and if that is also talking about ways in which we can essentially extend connect semantics so we can open up more streams and datagram channels, it seems like it could have a lot of similar properties here. And if that solution does require some level of HTTP work, I'd rather see more unified solutions across the board, across these different groups. But I think we should cull things down some way or another.
Yeah, my personal feeling is that if we go with pooled options, that makes an appealing prospect of like seeing whether MASC and HTTP free transport can be layered on top of each other. But yeah, I agree with that.
Thanks, Tommy. Lucas, who remembers?
Yes, sorry about that. It was a kind of minor and more administrative point, really. One of the slides noted a dependency on Skenazi H3 datagram draft, which I'll note isn't adopted anywhere, and I just wondered if that document was in scope for Webtrans group, or if you're looking for another home for it. And obviously, that decision depends on the outcome of the discussion that we're having right now.
Let me answer that as author of that individual draft, and I'll let Emnat jump in as well after as the chair of HTTP. I haven't looked for a working group for this yet. I think HTTP-BIS sounds like the natural approach, but if we see that there are multiple other working groups like Webtrans and hypothetically Mask that will have a need for it, then I think having it in one place that's already exists, like HTTP, sounds like ideally the best strategy. And Mark, if you want to jump in, go ahead.
Yeah, just this is something that's been talked around in the background in HTTP-BIS. It's not been on our agenda yet, but I think there's an expectation that it's going to have around there.
Okay, thank you.
Yeah, and I'm happy to bring it to HTTP-BIS if there's a virtual interim meeting happening soon. All right, Jonathan Lennox, you're next.
Yes, so I think one consideration which probably needs to be looked at when we decide is I was trying to think through how the various requirements that RIPS presented would apply to this, and they seem to want to simultaneously send signaling and media over a single connection while using an HTTP-based API for the signaling, which has implications for what transports get used here. And maybe if you want to say, no, that's stupid, don't do that, which is a fine answer to give them. But if we take those requirements seriously, that has implications here. And I think working through that exercise and seeing what it would look like is probably a useful thing to figure out what should happen here.
So yes, one point of comparison that I did not, I think, was pointed out is that with HTTP transport, you can always change headers on the connect stream, which provides a good opportunity to do the handshake in some unified way. And I think it might be very convenient for cases like offer answer or other like negotiation. But this is, of course, just like this. You can implement that on top of both. It's just the question of does it make sense and can we reuse existing things if we're running on top of HTTP.
All right, it looks like we've drained the queue. Bernard, do you want to take it to the next agenda item?
Since we have time, and before that, can I ask Fox in the room a question?
Sure, go ahead, Victor. We have time. The chairs want to start the wrap up in 25 minutes, so feel free to ask as many questions as you want.
I have one question and one higher level comment. So the question I have is to the audience, but especially to Martin and Ecker, since they said that we're not arriving to consensus here, and we're obviously not arriving to consensus here. What do you think would be the best way forward to actually make decision on this?
So for me, at least, I would like to see.
Please state your name.
David Skenazy. I'd like to see a lot more discussion here about the pros and cons on the mailing list and what people think would be deployable in their infrastructure and those sorts of questions before we make a decision about this one.
Not Martin Thompson, but actually Eric Rescorla. So, I mean, I think, yeah, I basically agree with Martin. I think, I mean, I think the other thing is like, it seems pretty clear we have like some sort of like, we now have 3 separate like attempts to like layer CRUD on top of Quick that sort of vaguely are HTTP-ish and have some integration with HTTP, and like having Mask ripped and this all kind of like adopt slightly different approaches seems like sort of super suboptimal. And maybe they all have different requirements. That's always possible. But especially when I heard Sir Justin Aberti say yesterday that he thought that that it'd be desirable to be able to implement ripped on top of web transport. That clearly seems like some kind of like interdependency. And I guess I heard some arguments in favor of both the sort of the Webby version and the quick versions. I think that kind of get those better fleshed out. In particular, I think that the arguments, some of the arguments in favor of the sort of quick version as opposed to the H3 version seem to be about like getting particular performance properties, and I think I'd like to understand whether it's possible to get those performance properties with the H3 version and whether we need them.
Thanks, Eric. Colin?
Colin Jennings. I think part of why you see these all being developed multiple different places at the same time is we've had, a couple of years of saying we want this and a couple of years of the quick working groups not yet really having a direction and charting for us. So I think the quick working group needs to, some priority on that. I hope, the datagram draft goes forward. We need some idea on top of that. I think that largely that what people want to build on top of this, that there's a lot more in common between the requirements than differences. So I think that we just need some direction of what's going to happen at that layer and what's going to be available, make sure the requirements are right. And these things will, instead of looking like 4 different things, will all look like, yeah, sure, we can use that. I don't think the requirements are very different. Hope that helps.
One point I'll add to that, David Skenazy, as the one of the authors of the datagram draft, just wanted to let you know that it's been adopted by the quick working group and we're making good progress there. The draft about like datagram and HTTP3 hasn't, but we're going to have those conversations soon.
Okay.
Since I assume the queue is empty, I said I have one question and one comment. So I've asked my question. The comment is, so the quick transport, as described in the draft, as I said, it's simple, and it's currently being implemented in Chrome. So if folks in this room would be interested in, so it's behind the flag right now, and it already works, but if the folks in this room would be interested in trying it out and providing like specific feedback, especially feedback for in terms of performance and what do we need in terms of like what other people I will send the link, and if people have specific questions, they should reach out to me. And eventually this might go into a Chrome origin trial, which is like a limited field testing. But as I said, since it's an origin trial, it is like we're completely not committed to actually shipping that specific thing, just to make sure that people understand that this is not getting shipped, and we will ship whatever we decide to keep of like the 4 transport in the transport zoo. I think the next one are the share slides and the wrap up.
Bernard, if you're saying something, we can't hear you.
Okay, yeah, there we go. So in this part of it, I think we wanted to keep track of our next steps and action items kind of going forward, making sure we've got everything noted in the minutes. So I heard a couple of things for next steps. One was that you may have noticed we did not do a call for adoption of the overview in this meeting, but presumably we will take that to the mailing list. So I think that is a next step. We've heard people ask for performance requirements to be articulated on our mailing list. I think that that's probably pretty helpful with respect to some of the size of some of the headers and the datagram latencies and stuff like that. So that's another action item. Let me see, David, do you recall some other things that we need to follow up on? Obviously, we need to get the GitHub repo together so people can start to file issues on various aspects of things. We'll kind of do that after the meeting. Are there any other kind of action items and follow-ups that people really think are important for us to pay attention to in the weeks to follow? Martin, do you have an opinion? Okay, go ahead, David.
So on the topic from earlier, the overview document, I think folks can expect a call for adoption on the list to come out soon.
Yeah.
Because I think that is the first milestone in our working group, and so far we haven't heard any strong objection to using Victor's draft as a starting point. And if folks have strong opinions, they can feel free to join the queue now. Otherwise, they're obviously welcome to answer when we do the call for adoption on the list.
Yeah, we probably also should have a repo when we do the call for adoption, because people will read it and have issues that we should allow them to file.
That's a good point.
Yeah, another thing I think is worth following up on is, and Alan just put this in the Jabber room, is the whole list of requirements relating to datagrams in H3 and stuff like that. I think that may come out of the performance requirements once we get those articulated. And as Mark noted, there may be discussion in HTTP-BIS, which may help articulate some of that. Are there any other next steps or things people think need to happen?
I think we're going to be able to end early. It's exciting.
Okay. Yeah, another thing just for the RIPT folks is to kind of get some of your thoughts on what's missing here or what you're looking for, just to make sure that we understand all the requirements that came out of that. Yeah, Jonathan, if you have any comments, we'd like to have them on the mailing list.
I'm not sure I understand RIPT well enough to say specifically, but I think I was perhaps encouraging the RIPT proponents to push their requirements over.
Yeah. And of course, feedback on all the existing documents is welcome, the HTTP transport, HTTP3. I think we're going to have to sort through also the number of transports and what we want, but having requirements may help us do that, to understand what we're trying to cover with all of these transports. And also, I think it may be helpful to get clarity on the fallback issues. You know, I think it was proposed that basically it's HTTP2 or nothing, or
we have folks joining. We have folks joining the queue. Martin Thompson, go ahead.
Yeah.
So Martin Thompson, I think we have a fair bit of clarity over the sort of functional requirements that Victor went over, the ability to send streams and datagrams and whatnot. But I think the requirements that we need more clarity about is how this all integrates with existing HTTP infrastructure, and that will motivate some of the decision between the pooled or dedicated columns that Victor had in his presentation. That to me, I think, is where the requirements are a little bit lacking.
Thanks, Martin. Mo?
Yes, Mo Zanatti. I wouldn't hold my breath for getting all the RIP requirements written down well, because I believe there's still quite a bit of work in RIP to get the core requirements, which are going to be first directly over H3, not through any Webtrans abstractions of it. So I think there's going to be, quite a bit of work to get that fleshed out first to understand the core protocol, and then we'd probably be able to tackle the Webtrans bindings if needed.
Thanks, Mo. Victor?
Yeah, I'm going to try to clarify requirements, and not just requirements, but specifically the use cases and what I've heard from different people who want different things, because there are, as Martin noted, there are like trade-offs in terms of things like complexity, then in terms of infrastructure. And for instance, there are lots of people. The reason I even am worried about complexity in first place is that one of the motivations behind Webtrans work was that we reached out to people who are developing games for the web and asked them whether they're interested in using RTC data channels, and all of them basically came back sometimes months later and said, this is too hard. And that is like the main reason I'm worried is that we got pushback on that. On the other hand, for instance, there are people who are really interested in using this with load balancing, and my understanding is that, for instance, Facebook already implements some version of HTTP2 transport, and they have deployment experience with how that works. So that also might motivate that. And there are other people who have their different priorities in that respect, and I will try to summarize most of them on mailing list.
All right, thank you, Victor. Bernard, I think that's a wrap. Do you have anything? All right, so thanks everyone for coming. As a reminder, if you have not filled the blue sheets in the Etherpad, please head over to the IETF agenda page, and there will be a link to the Etherpad, and add your name there. Otherwise, thanks everyone for coming to IETF 107, and I think we're done for the week.
Stay safe.
All right, bye everyone.
Bye.
Bye, folks, and thanks for the IETF.
See you in Madrid, maybe.
Bye-bye.